June 1998. About 1 million miles from Earth, a spacecraft the size of a small bus was turning slowly in the dark. Its solar panels had swung edge-on to the sun, so it made no power. The batteries were dead, and the fuel had frozen solid in its pipes. It couldn't hear us, and it couldn't answer. For nearly a month, the people who built it had no idea if it was still there. Then a giant dish in the hills of Puerto Rico fired a pulse of radar into that empty patch of sky to find out. That machine was called SOHO. It was a joint European and American observatory, and its whole job was to stare at the sun and keep watching, without a break. It had been doing that job perfectly for 2.5 years. Then, in the space of a few hours, on a night when nothing was supposed to happen at all, it went dark, went silent, and started to spin. And nobody on the ground could stop it, because by the time they understood what was wrong, there was nothing left on the spacecraft that could hear the command to fix it. I went looking into this story because I expected it to be a small, sad footnote. $1 billion machine, lost to a bad night, written off. Every part of that guess turned out wrong. What actually happened is one of the strangest, most stubborn rescues in the history of spaceflight, and almost nobody outside a few control rooms knows it happened. Stay with me, because the best part comes after the rescue. It's what they found the machine could do once most of the equipment that was supposed to keep it alive had already failed. That part rewrote how we fly spacecraft, and the machine at the center of it is still up there right now, working, decades past the short mission it was ever meant to have. To understand why losing this thing felt like a punch in the chest, you have to understand what it actually was, and where it sat. Most satellites orbit the Earth. SOHO sits somewhere stranger, at a spot called the First Lagrange Point, L1, a place about 1 million miles out where the pull of the Earth and the pull of the Sun balance so neatly that a spacecraft can more or less hover there, between the two, looking straight at the Sun with the Earth at its back. That is an incredible piece of real estate, because it means SOHO never has the Earth swing in front of its view. It gets an unbroken, around-the-clock stare at the star that keeps us all alive. And the star it stares at is not the calm yellow disk we picture. Up close, the sun is violent. It flings out storms of charged particles, and sometimes it hurls a coronal mass ejection, billions of tons of plasma thrown off the surface at more than 1 million miles an hour. When one of those is aimed at us, it can knock out satellites, scramble navigation, and in a bad case, take down power grids on the ground. SOHO was our tripwire for that. With 12 separate instruments, it watched for the storms coming and bought us the hours of warning that let operators brace for the hit. Some of its instruments photograph the sun's outer atmosphere by blocking the blinding disk, the way you'd shade your eyes with a raised hand. Others listen to the sun ring like a struck bell, reading sound waves moving through it to map what's happening deep inside. It turned the sun from a flat circle into something we could actually watch behave, day after day, storm after storm. Here's a detail that tells you how good this machine's eyes are. SOHO was built to study the sun. It has, as a pure side effect, become the single greatest comet hunter in human history. As comets fall in toward the sun and vanish into its glare, SOHO catches them on the way in. By early 2024, it had found its 5,000th comet. More than half of all the comets humanity has ever discovered were spotted by this one spacecraft that wasn't even looking for them, which is a strange thing to call a camera. This was an observatory that quietly rewrote 2 different fields of science at once. So when it went quiet in the summer of 1998, one of the most valuable eyes we had ever put into space was going dark, for reasons nobody on the ground could immediately explain. And this is the part I keep coming back to about how it happened. The spacecraft didn't break. There was nothing wrong with it. Every piece of hardware on SOHO was working exactly as designed on the night we lost it. What failed was on the ground, and it failed the way most disasters actually fail, which is quietly, in small, reasonable steps, none of which looked like a catastrophe on its own. It started more than a year earlier, with a decision that made complete sense. SOHO steadied itself using gyroscopes, spinning wheels that sense which way the craft is turning. Gyroscopes wear out. So in early 1997, the team modified one of their standard procedures to let a gyro spin down and rest during the stretches it could be spared, to make it last longer. It was a sensible, careful call. But that modified procedure quietly dropped one small command, the instruction that was supposed to wake the gyro back up and spin it if the spacecraft ever fell into its emergency safe mode. Nobody noticed. The safety net had a hole cut in it, and the hole sat there, harmless, for over a year. Then, in June 1998, During a routine set of calibrations, a second small thing went wrong. A different gyro, the one watching how fast the craft was rolling, got left in the wrong setting during the maneuver, and in that state it was reporting the roll rate as 20 times faster than it truly was. So now the spacecraft's own instruments were disagreeing with each other. One gyro, spun down and resting, read almost nothing. The other, in the wrong mode, read a wild spin that wasn't happening. And that's where the third thing happened, the human one. Faced with two sensors telling two different stories in the middle of the night, the team made a fast call. They decided the gyro reading the fast spin was the broken one, and they switched it off. But that gyro was working perfectly. It had been the only one still telling them any version of the truth, and with it gone, the spacecraft was blind to its own rolling, firing its thrusters to correct a spin based on numbers that were completely wrong. It threw itself into a real tumble. It dropped into that emergency safe mode, reaching for the automatic recovery that should have saved it, and the command that would have woken the gyro back up, the one quietly deleted a year before, wasn't there. The safe mode couldn't save it. The craft spun up, swung its solar panels edge on to the sun, lost all its power, and went silent. I want to be careful here, because it would be easy and wrong to point at those controllers and call them careless. The joint European and American investigation that followed was blunt about it. There were no villains. What there was instead was a modified procedure that hid a flaw, a workload thinned out to save money, and 3 small errors that happened to line up in the dark. Every person in that room was making a reasonable call with the information in front of them. That is what makes this kind of failure so hard to stamp out. What lost SOHO was never a person in that room, it was a process that had quietly stopped protecting the people running it. Whatever the cause, the result was the same. SOHO was gone. Spinning, frozen, dark, a million miles away, and completely deaf to anything we sent it. In the days that followed, the mission tried everything. They aimed the big antennas of the deep space network at the patch of sky where the craft should be, and listened. Nothing. They sent commands blindly into the void, hoping something would land. Nothing came back. Weeks went by. The people who had spent years of their lives on this machine were now, in every practical sense, holding a funeral for it, while trying very hard not to say so out loud. Now, this is the part of the story where you meet the people who refused to let it go, and there wasn't just one of them. Getting SOHO back was going to take 2 completely different problems solved by 2 completely different kinds of expertise, and the first problem was the strangest. Before you can rescue a spacecraft, you have to know where it is and what it's doing, and SOHO couldn't tell them. A dead, silent craft doesn't broadcast its position, and it can't tell you it's spinning once a minute. So the recovery team was facing a question that sounds almost childish and turns out to be brutally hard. Is it even still out there, in the right place, in one piece, or are we about to spend months trying to rescue a cloud of debris that used to be a spacecraft? The answer came from a technique that had almost nothing to do with the way we normally talk to spacecraft. If SOHO wouldn't send them a signal, they would bounce one off it. They would treat this delicate scientific observatory the way you'd track an asteroid, by hitting it with radar and reading the echo. And to do that a million miles out, they went to the one instrument on Earth big enough to try. The Arecibo Observatory in Puerto Rico, a radio dish 1,000 feet across, slung inside a natural bowl in the hills, the most powerful thing of its kind ever built. On the 23rd of July, 1998, Arecibo aimed at that empty patch of sky and transmitted. The pulse crossed a million miles of space, and if the team had it right, some tiny fraction of it would glance off the hull of a tumbling spacecraft and come limping back. But there was a catch that tells you exactly how thin the odds were. The round trip would take seconds, and in those seconds the Earth would turn just far enough that Arecibo itself could no longer see the target. So Arecibo could shout, but it could not hear its own echo. The second dish, 70 meters across, out in the California desert at Goldstone, was pointed and waiting to catch the whisper that came back. One antenna to send, another, a continent away, to listen. And then the wait, while a signal crossed 2 million miles of space and everyone held still to see if the dark would give anything back. And it came back. Out of all that dark, the echo returned, and the numbers buried in it told a story. SOHO was still there, sitting in its orbit, near L1, right where it should be, and slowly rotating, about 1 full turn a minute. It was not a cloud of debris, it was a whole spacecraft, cold and asleep and spinning, waiting. For the first time in a month, the team knew their machine was solid enough to be worth saving. But finding it was not the same as reaching it, and a frozen spacecraft is still frozen. The radar had proved the machine was there, cold and asleep. Waking it up was a different job entirely. So they went back to the radio, aimed now with the confidence that something was actually out there to receive it, and they waited for the slow geometry of the orbit to help them. As the spacecraft tumbled, its dead solar panels would occasionally swing back toward the sun and catch a few minutes of light, enough to trickle a little charge into the flat batteries. The team's bet was that if they were listening at exactly the right moment, they might catch the craft flickering briefly to life on its own. On the 3rd of August, it happened. A station in Canberra, Australia, caught it. Just a raw burst of carrier signal, the spacecraft's radio coughing once in the dark. After 6 weeks of silence, SOHO had made a sound. A few days later, they pulled down the first real telemetry, the machine's own report on its condition, and it was grim reading. The craft was frozen far below anything it was designed to survive, and the fuel it needed to point itself back at the sun, its hydrazine, had frozen solid in the tanks and the lines. You cannot fire a thruster full of ice, so the rescue turned into something that sounds almost tender. Over weeks, using the tiny amounts of power they could scavenge each time the panels caught the sun, the team began to gently warm the spacecraft from the inside, running its own heaters to thaw its own frozen fuel, a million miles away, with no way to touch it, and barely enough electricity to try. The tank heating alone ran for 275 hours. They were, in the most literal sense, thawing a machine back to life across the solar system. It worked. By the 16th of September, they had enough thawed fuel and enough control to turn SOHO's face back toward the sun. The panels drank the light, the batteries filled. On the 25th of September, 3 months after that silent night in June, the spacecraft came back to full working order. And when they carefully switched the 12 instruments on again, one by one, through October, they braced for the damage. A precision observatory had just spent months frozen far below its limits. Surely something had cracked, or warped, or died in there. Nothing had. Every instrument came back. The deep freeze had not destroyed the eyes. SOHO was whole. And that, honestly, would already be a good enough story. A dead observatory, found by radar, thawed across 1 million miles, brought back intact. But it's here that the story does the thing I actually find remarkable, because the machine wasn't finished being tested, and it was about to reveal that it could do something nobody had ever built it to do. Remember the gyroscopes, the spinning wheels that let SOHO know which way it was turning? They had been at the center of the original disaster, and in the months after the recovery, they started to fail for real, one after another, worn down by the whole ordeal. By the 21st of December, 1998, the last working gyroscope on the spacecraft died. For a machine like SOHO, this was supposed to be the end of the line. To keep its instruments locked on the sun, it has to know its own orientation to a tiny fraction of a degree, and the gyros were how it knew. Lose that sense of your own motion, and the stare drifts, the images smear, and the science stops. And for a while the team held it steady by hand, firing thrusters in careful little bursts to keep it pointed, burning through about 7 kilograms of precious fuel every week. That could not last. At that rate, they were watching a clock run down toward the day the tanks ran dry and the mission ended for good. So the engineers asked a question that, as far as anyone knew, had never been answered. Could you fly a 3-axis spacecraft and hold it steady enough to do real science, with no gyroscopes at all, as the permanent way of running it from then on? Every spacecraft of this kind ever built had carried gyros precisely because the answer was assumed to be no. And they figured out that you could. They rewrote the spacecraft software so it used the wheels already spinning inside it, the reaction wheels it turned with, as stand-ins for the dead gyros, reading its own motion from the machinery it already had, and cross-checking that against a sensor watching the stars. They turned the spacecraft into its own gyroscope. On the 1st of February, 1999, SOHO went back to normal operations with no working gyros on board, and it held its stare. It became the first 3-axis spacecraft ever flown without a gyroscope. And it worked cleanly, so well that the emergency stopped being an emergency and became, simply, the way SOHO lived from then on. Think about what that means. The capability had been sitting inside that spacecraft the entire time, unused and unknown. Nobody designed SOHO to fly without gyros, and nobody knew it could. It took losing almost everything that was supposed to keep it stable for a team on the ground to discover that the machine was more capable than the people who built it had ever realized. The whole fix lived in software and patience. The ability had been inside the machine the entire time, waiting for someone desperate enough to go looking for it. I said at the start that the best part comes after the rescue. This is it. We reached out and touched a dead machine with radar, thawed it back to life, and then, when its most critical systems failed anyway, we discovered it had a way to survive that its own makers never knew about. The system turned out to be more capable of recovery than anyone studying it believed, and the people running it just needed to get out of the way long enough to let it prove that. Now, there are 3 things about this I can't leave out, because they're the parts that never came right, and a story like this is only worth anything if you tell those 2. Start with the fuel. That gyroless triumph is real, but it isn't free. Holding SOHO's precise stare still leans on small thruster firings, and every firing burns hydrazine that can never be replaced. The mission has managed that fuel with extraordinary care for decades, but the tank is finite, and one day it will be empty, and there is no fixing that from Earth. All they did in 1999 was slow that clock down. It is still running. Then there is the hardest one, and it's the kind of thing only time can do to a story. The rescue depended on Arecibo, that enormous dish in the Puerto Rican hills, the one instrument on the planet powerful enough to bounce radar off a dead spacecraft a million miles away and read the echo. In December of 2020, after years of storm damage and snapping support cables, the Arecibo telescope collapsed into the bowl beneath it. The great dish is gone. The exact move that found SOHO, that first reach into the dark, that proved the machine was still there, could not be made the same way today, because the instrument that made it no longer exists. The tool that saved a spacecraft outlived its own triumph and then fell into the jungle. There is something in that I find genuinely hard to sit with, and the deepest limit is the one that started the whole thing, and it's a human one. SOHO was lost to a thinned-out ground operation, a quietly modified procedure, and the ordinary pressure to do more with less. The recovery was heroic. But the conditions that caused the loss, the budgets and the schedules that shaved the margins off complex operations, those pressures never went anywhere. We got lucky that this particular failure happened to a machine we could still reach. The next one might not be. So what do you take from a story like this? I think it's a caution against how fast we write things off. It applies to far more than spacecraft, to anything complicated and expensive that looks finished. The instinct, when a system goes dark, is to declare it dead and move on, because hope is expensive and failure is embarrassing. SOHO is a standing argument against that instinct. The people who ran this rescue kept refusing to hold the funeral, week after week, when every reasonable person would have understood if they'd stopped, and what they got for it went well beyond their machine back. It was the discovery that the machine could do more, half-broken, than it ever had whole. And in the end, the real work was done by the machine itself. The engineers were brilliant, but what actually saved SOHO was the resilience that had been designed into it and then hidden even from its own designers. All the radar and the heaters and the rewritten software really did was give a fundamentally sound spacecraft the chance to show what it still had left. It took that chance, and it has not stopped taking it since, because this is where the story actually lands. That single pulse of radar, fired into an empty patch of sky in the summer of 1998, just to see if anything was still there, something answered, and the quiet, strange truth is that it never really stopped. Out at that balance point between the Earth and the Sun, the machine is still at its post, watching the star we orbit and catching comets nobody sent it to find. Somewhere right now, there is a screen with a live picture of the Sun on it, sent home by a spacecraft we mourned for 6 weeks and then thawed back to life. A spacecraft flying blind by a trick its own builders never knew it had, decades past the brief mission it was ever promised. We reached into the dark to ask if it was still there. It hasn't stopped answering since. Spaceflight is full of these, the machines everyone signed off as lost, that turned around and outlived the verdict, and almost none of them get told properly. If that's the kind of story you want more of, subscribe and I'll keep digging them up for you.